Okay, today we are looking at a bus that was originally built with the system, solar system, and it then went later to a second guy to modify and make work. It's a full-size bus. It's got 2,000 watts of solar on it. We've got 4 battle-born, 12-volt battle-borns on this side. And we've got 4 12-volt battle-borns on this side. Now this one, it looks like they're pulling from both ends, so that's interesting. They've got a fuse here and a fuse there, but I'm sure they're loose because all of them have been so far. And the other side, I pulled the fuse out because it was all loose and got her limping just recently at the Skoolie swarm. So this one's not pulling from both sides, it's pulling from just the one side. Now this is the inside. We've got the 12/3000. That's a 2400 watt inverter, and that's not big enough for what this bus has. The bus has 2 mini splits. It's got 2,000 watts of solar. 12 volt is not appropriate for this size bus and the needs that are here. There's also an auto transfer switch, which there's one of those built in to this, and there's one AC input for this inverter. When you go to the second inverter, the second larger inverter, the 5000, you wind up getting 2 AC inputs. So doing something like this isn't necessary in order for you to have both a shore power option and a generator option. So there's a lot going on here, but just right from the start, I can go through and you can see we've got a lot of loose connections all over. Something's going on there. I think that's a second battery bank. And while those connections are also loose, that one's just not even connected. So one side's not even working, is what it looks like, is not connected. This battery monitor, the BMV 712, that is also not functioning. She's got no access to it. And there's no ground, as you can see right there. So there's also something going on up here. I'm not sure what. We've got 2 panels. I've got to go backwards and figure out what's going on here. But it does look like this black cable here that's sloppily wired to this panel is going to be the AC output 2 from the Multiplus, which means that panel only works when you are plugged into shore power. So we're going to get that sorted out, and I'll check back here in a little while. Those entry ports there are you just skip the way to make it pretty, so we're going to get it patched up. Upon closer inspection, we've got just random hardware being used in the batteries. These batteries ship with hardware, and that hardware has a lock nut and a lock, and it has a washers and a lock nut. And here they just kind of skip those. I don't understand. It comes with it, it's included, and it keeps them nice and secure. This one's missing a washer. It's just random, and we'll see what this rail's made out of. It looks like it's aluminum. Oh, yeah, I don't know. I've had a chance to look over the system, look a little more deeply into what's going on. I haven't mapped out everything yet, but right from the start, just like I pointed out with the Battleborn, they come with hardware. If you notice here, on this one, you've got the nut, you've got the lock washer, then the washer. On this one, you can see there is no lock nut. And, you know, the lock nut's real simple. It looks like that, right? That copper guy, right there. I think it's copper. Well, this one doesn't have it, and that's what you get. So this has been loose the whole time. That's generating heat, and actually she was having low battery. So when she pulled even a little hard on this, she'd get low battery. It would shut this thing down. This guy was also loose, but I went ahead and pulled it off, and just to point out something. One, they do have the correct sized lug terminals, so that's nice. Oftentimes, this the lug size, the lug eyelet is larger, and so it's kind of loose, dangling. But if you notice, that base plate, this metal ring right here, there's not a lot of surface contact with such a large circuit like this. So something this 250 amp range, I don't even bother with using breakers like this. And in fact, even the breakers I use, which I use 100 amp breakers and below, like this, just not this brand. But the ones I get have it's a very specific model that has a full square plate in there, so you're getting all of the contact surface on the lug. All right, I've figured out what was going on here. They've made this insulated bay with this cutout foam, but you know, at the very bottom, it's directly to the metal. So I don't know how effective that would even be, and if it would cause them actually to heat up and shut down before they got too cold and shut down. But regardless, what we have is this is the end of the line of all these batteries. So these are the first, we'll call them the first four. They've got this bus going across, and they went to a fuse. Then same thing on this negative, that was connected to the bottom. So fortunately they put some tape around here, so that's keeping it from doing too much of the sparks, but I've got the other side disconnected. So then the positive and negative from these two wind up shooting underneath to the other side, and it coming into here where they also had another fuse. And these fuses weren't great, they're not secure, and these are held in with these like compression style fuse holders, which I really don't like. I like lugs. So these are held in by like an Allen wrench or something up top. I'll show you that in a little bit. And then we're coming over here across these batteries to the positive negative, which then goes inside the bus. Just very interesting. It winds up in unevenly pulling power from these batteries. So just down the whole line to the other side, the very last batteries aren't seeing much of a pull at all, especially under higher loads. It's really not optimal. It works, but it really isn't optimal. I said a moment ago that I don't like the way these guys work. They're held in by something like that versus a lug. So I'll give an example here as to why that is. And that one I just showed you came apart in my hand. So we'll see if the same thing happens here. No, that one's holding better. Well, better, but see how tight these are. Oh, yeah, see? Didn't even need two hands for that. Yeah, see that? That's no good. I bet if I pulled hard enough and wiggled this one, it'd come right out as well. Let's see. That's yep. Very, very unsafe. All down the line, we've got these loose connections all over. Not optimal in any way. And that said, they do have grommet protection. Gotta give them that. On this bus, there's a bunch of proper crimps, but I've seen this one here a couple times now. And if it's like the others, uh-oh. This is why I don't use existing cables in a bus I'm redoing. Now after a few days, I've got this thing patched up. All the batteries are out of there, consolidated them to the inside, upgraded the inverter to a 4,000 watt Victron. Let me get this a wider angle. Don't judge me by my carpentry. I'm not a woodworker, but we've got the two sets of pair of batteries 4 times into the Lynx power in, keeping even distribution, even pulling from all the batteries. The top tray is accessible, so if we need to service the system, it can be done. Had to integrate some of the original wiring to keep things simple, but links distributor. It's got all the fuses that are appropriate. We've now got a Sterling DC charger that produces about 800 watts when the engine's running. We've got the charge controller, 12 to 24 volt, 24 volt to 12 volt controller, and now we've got a proper breaker on the solar side coming in. Everything's breakered, fused how it needs to be. Still a bit of a mess, but much better than it was before. On and off switch, master, fuse, and breaker combo. And I've gone through the whole system, got it all programmed properly. Had to tie both of these panels together in a way that was safe and appropriate without rewiring absolutely everything, but we've got it going. Now we're running both mini splits, no problem, nothing's shutting down. And the system is now safe and appropriate as it should be. While she was here, we also got the shore power done properly. I'm going to tie some of this extra up, but so we got 30 amp shore power here, programmed for on the Victron for 22 amps. So that's going to pull 22 amps from this generator, which we did a service on, oil change, got all that up to speed. And then on the other side, we've got the 30 amp shore, but this one we just have an adapter with an extension cord. The Victron's programmed to only pull 13 amps from this, so at any point she can just plug into an extension cord as she's been doing and power the entire bus off of just the 13 amps should she need to.